In these examples, we're asked to evaluate the following expressions and to write our answers as integers or reduced fractions. So notice there's 6 problems here, and let's start with the first one and try to come up with a general strategy. So I'm going to put this one down here. We have 3x squared minus x, and we're told x equals -5. Well, to evaluate this expression for x equals -5 means to replace the x with a -5 and then follow the order of operations. Let's try to make the practice of whenever we replace a letter or variable with a quantity, let's put the quantity in parentheses, and you'll see why. So I'm going to copy down the 3. Instead of the x, I'm going to write -5 in parentheses. I copy down the squared, minus, and now I have x, and I'm going to put -5 in parentheses again. Okay. So now we've replaced all of the x's with -5s. So now we're just going to follow the order of operations, and remember the order of operations are parentheses, exponents, multiplication and division, and addition and subtraction. And notice that I wrote them this way because multiplication and division actually have the same order working left to right. Meaning if you have a problem you have to evaluate and it has both multiplication and division, if the division is further to the left, you do that first. If the multiplication is further to the left, you do that one first. And the same applies for addition and subtraction. So let's highlight as we go so we can keep track of what we're doing. So first we have parentheses written here, but notice there's no operations to perform in the parentheses. This is just a number -5 and the same here. So no parentheses, no operations in parentheses to perform. Next we're going to do exponents. So here's our exponent, and we're asked to raise -5 to the second power. So I'm going to do this on the side, and then we'll put in our quantity. So -5 to the second power means 2 factors of -5, or multiply -5 by itself twice. A negative times a negative is positive, so our result is 25. So now I'm going to replace this with 25. And now I'll copy down the rest of the expression. Okay, so notice I kept this quantity in parentheses again because we're going to be multiplying. The operation implied between 3 and these parentheses is multiplication. So right now we have multiplication and subtraction. We're going to do multiplication first. Let's highlight what we'll do next. So 3 times 25 comes next. And I'm going to do this work on the side. 3 times 25 is 75. So now I'm going to replace this with 75 and copy down the rest of the expression. And now we just have one more operation to perform, and that's subtraction. Now we're going to do this. And remember, one way to think about subtracting a negative number is it's the same as adding the opposite of the number. So I'm going to rewrite this as 75. Instead of subtracting -5, I'm going to add +5. So 75 plus 5 equals 80. And that's our final answer. Put that in the box up here. Okay. So let's just stop and think about what we did to evaluate an expression. We first replaced the letter or variable with the given number. And remember, we did that in parentheses, meaning we put the number in parentheses. And this was important. Here, when we put -5 in parentheses, it was important that we saw that we were squaring the -5. So since x is -5, that's what you want to square. If you didn't put it in parentheses, you might think it was a subtraction sign or something else. Then we evaluated using the order of operations. So that's our basic strategy here. Okay, let's try this next one. We have evaluate 5 over 3x for x equals 3. So now the first step is replace a letter or variable with the given number in parentheses. So there's only one letter x here. So I'm going to replace it with the given number 3. Okay. Now, we have a numerator and a denominator, and we can consider a fraction division, but notice they want us to write our answer as a reduced fraction. So we only need to do the multiplication in the denominator. That's the only required operation. And 3 times 3 is 9. And our final result is 5/9. So let's put that up here in the box. Okay. Now let's try the next ones. I made some more room for computations. Now evaluate the absolute value of n. So these bars mean absolute value of n for n equals -3. So now I'm going to replace the n with -3 in parentheses. So now we've replaced it. Now in this case, the parentheses aren't really necessary. I know that because there's no other operations around it. I'm not multiplying it by anything else or raising it to an exponent. So I can actually drop the parentheses in this case, and it may make the expression a little bit easier to read. So we want the absolute value of -3. Well, absolute value means what is the positive distance of the number from 0? Well, here's 0, here's -3. Notice the distance is 3. So our final answer for this one would be 3. Let's try the next one. Evaluate 2 raised to the x power for x equals 8. So 2 to the x for x equals 8. So I'm going to start by replacing the x with an 8. Okay. And again, here the parentheses aren't really necessary because 8 is the only thing in the exponent. So I didn't put the parentheses in there to save time. So this means multiply 2 by itself 8 times, or 8 factors of 2. So 1, 2, 3, 4, 5, 6, 7, 8 factors of 2. Okay. So this may seem like a lot, okay, and you could do this on your calculator, but I'm going to just multiply 2 at a time. So let me get a different pen. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and I'm basically just doubling. That's why it's not that hard. 32 times 2 is 64. 64 times 2 is, doubling that, is 128, and 128 times 2 is 256. So our final result is 256. Let's look at our next one. Evaluate 2r in parentheses raised to the third power for r equals -2. So first I'm going to replace r with -2, and I'm going to put it in parentheses. Okay, and this may look a little bit messy, but remember this is 2 times r. That's what this means. So this means 2 times -2. And since that's what's in parentheses, remember we had PEMDAS, we have to perform the parentheses before we do the exponent. So 2 times negative 2 is negative 4. And then we have the third power. And now we want to write 3 factors of negative 4 to evaluate the exponent. And I'm going to multiply these one step at a time again. So negative 4 times negative 4, well, a negative times a negative is positive. So this would be 16. And 16 times negative 4, well, a positive times a negative is negative. And 16 times 4 is 64. Okay, you could do that using the algorithm or on your calculator. And we have negative 64 as the result. And now we have one more example. 1 over n squared, where n equals negative 9. So first I'm going to replace the n with negative 9 in parentheses. Negative 9 squared. And then on the side, I'm going to compute negative 9 squared. So negative 9 times negative 9. Well, a negative times a negative is positive, and 9 times 9 is 81. So this equals 1 over 81. And notice that was the only operation we needed to perform, was the exponent in the denominator, and this fraction is simplified. So our final result is 1 over 81. And we're done.